Number 1. Alternating voltage and current. Number 2. Direct voltage and current. Number 3. Semiconductor diode. Let's discuss these three things one by one. Alternating voltage and current. When available voltage from an electrical source changes its direction periodically, the voltage is known as alternating voltage, and the source from which it is available is known as AC source. If we plot waveform of this voltage by drawing magnitude of voltage on y-axis with respect to time on x-axis, we will find that the waveform is sinusoidal in nature, which shows that voltage increases in one direction, achieve positive maximum amplitude, decrease to 0, then it changes its polarity, achieve negative maximum amplitude, and again reduced to 0. Now, if we apply this alternating voltage to an electric load, alternating current gets set up in the circuit. Flow of current follows the nature of applied voltage. This changing current is known as alternating current. Direct voltage and current. When available voltage and current does not change its direction with respect to time, then it is known as direct voltage and current respectively. For example, potential difference, or we can say voltage available at terminals of a battery or a cell, is direct voltage because it does not alter its polarity and remain constant in magnitude when time proceeds. Consequently, when we apply this voltage across an electric load, current will also direct in nature, means it does not change its direction and magnitude with respect to time. Semiconductor diode. It is an electronic two-terminal device, the two terminals called as anode and cathode. This device has a special property that it only conducts electricity when it is forward biased. Forward biased means when anode is at higher potential or positive polarity and cathode is at lower potential or negative polarity. In this case, the diode offers very low resistance to a circuit, or we can say that they behave like a closed switch. Whereas diodes, when reverse biased, means anode is at lower potential and cathode is at higher potential. In this case, diodes do not allow to electric current to passes through them, or we can say they behave like open switch. Now come to our main topic. Half wave rectifier. When available electrical supply is in alternating forms and required form is DC supply, conversion is required to be done, which is known as AC to DC conversion or rectification. The circuit used for this conversion purpose is known as rectifier. One of the type of rectifier is known as half-wave rectifier. The circuit diagram of half-wave rectifier is shown here. It consists of AC supply, a transformer to change the level of voltage, a diode, and a DC electric load, which could be an electronic device which runs on DC, a DC motor, or an electric bulb. Now let's understand the working. When AC supply is switched on, the alternating voltage VAB appears across the primary winding of the transformer. This high voltage VAB is reduced to the level which is suitable for the diode and the load at secondary winding, and it can be represented by VCD. When this alternating voltage VCD is applied across the DC load having a diode in series with it, what will happen? During positive half cycle, the terminal C becomes positive and the terminal D is negative. Under this condition, the diode is forward biased, which we can see here. The anode is at higher potential with respect to cathode. As a result, diode behaves like a closed switch. We have already discussed it. And this positive cycle appears across the load and current flows through the load resistor RL. This current varies in magnitude as shown here. In this way, the positive half cycle of output voltage V0 is equal to IRL, appears across the load resistor RL. During negative half cycle, the terminal C is negative and D becomes positive and the diode is reverse biased. Under this condition, the diode does not conduct and no current flows through the circuit. Therefore, during negative half cycle of the input, no voltage appears across the load resistance RL. This process will continue until any one of the source and load is disconnected. Thus, the output voltage V0 developed across load resistance RL is a series of positive half cycles of alternating voltage. It is obvious from the figure that the output is not a constant DC but only a pulsating DC wave. To make the output wave smooth, the useful in a DC power supply, we have to use a filter across the load. Since only half cycles of the input wave are used, it is called a half-wave rectifier. So, this is the complete description of working of half-wave rectifier. Hope you like it. We will discuss it in more details and different types of rectifiers in when available electrical supply is in alternating form and required form is DC supply, conversion is required to be done, which is known as AC to DC conversion or rectification. The circuit used for this conversion purpose is known as rectifier. One of the type of rectifier is known as full wave bridge rectifier. Here, full wave means the rectification, that is, conversion of AC to DC happens in both positive and negative cycle. And the circuit used for this purpose is similar to Wheatstone bridge. That's why this configuration of rectifier is known as full wave bridge rectifier. It consists of an AC supply, a transformer to change the level of voltage, 4 diodes named as D1, D2, D3, D4, and a DC electric load, which could be an electronic device which runs on DC, a DC motor, or an electric bulb. Now let's understand the working. When AC supply is switched on, the alternating voltage VAB appears across the primary winding of the transformer. This high voltage VAB is reduced to the level which is suitable for the diodes and the load at secondary winding, and this voltage at the terminals of secondary winding. Let's represent it by VCD. When this alternating voltage VCD is applied across the bridge configuration and the DC load, then what will happen? During positive half cycle, the terminal C becomes positive and the terminal D is negative. Under this condition, the diodes D2 and D4 is forward biased, which we can see here. The anodes of both the diodes are at higher potential with respect to cathodes, whereas diode D1 and D3 are reversed biased. As a result, the diodes D2 and D4 behave like closed switches. Therefore, current flows through the load through this path during positive half cycle in the direction A to B. This current varies in magnitude as shown here. In this way, the positive half cycle of output voltage V0 is equal to IRL appears across the load, where RL represents the electric resistance of the load. During negative half cycle, the terminal C is negative and D becomes positive, thus D1, D3 are forward biased and D2, D4 are reversed. Now current follow this path and it means again from A to B. Therefore, during both part of the cycle, current through load flow in same direction, that is from A to B. This process will continue until any one of the source and load gets disconnected. In this way, the given bidirectional alternating current gets converted into unidirectional DC. Hope this presentation gives you a little bit idea about how full bridge rectifier works. We will discuss it in more detail and different types of rectifier in our upcoming videos. Till then, thank you for watching and please like, share and subscribe.